Hi, hello to the first Automat stream. We'll start by coding a small, like a fun small toy example. So what we're gonna do today is, here is the Automat website. And, oh yeah, now you should be able to see it. So the background on this website is kind of dull. So the plan is to replace it with something cooler. We have this old Windows XP screensaver that used to draw Bezier curves. And the plan is to replicate it. So we will try to write a small website with some JavaScript code that will do exactly this kind of animation. Maybe not exactly. Maybe we can do better. So yeah, let's start. I have the main Automat repository opened here, and I will start with a completely fresh website. It's just easier to start with something fresh rather than adding it in the existing one. Bezier HTML, and let's also create Bezier JS. Some skeleton. Skeleton code. And the canvas. Cool. Let's preview our website. Maybe I will preview it in a proper browser. Oh yeah, it seems to work nicely. Cool. Now, the script. Actually, let's not use an external script. We will code inline. So to animate, we will use the request animation frame. This approach. To do this, we have to create a function and schedule it repeatedly. Oh yeah, and the copilot is already suggesting stuff. Okay, so we have a basic curve. Now we have to add more of them. How we could approach it? So one thing we could do is we could retain the canvas contents and not clear anything. In each tick, we would fade the background a little bit, move the Bezier curve and draw it again. And it's fairly fast and allows to create kind of cooler effects. If we can change, so if we retain the previous picture and draw on top of it, we can also use some fancy drawing modes like overlay to kind of boost the colors of the picture. Yeah, so I think this is what we will do. So to clear the image, we will draw something that's yeah. Okay. Looks alright. I guess we can move it. How do we draw text? Okay. I wanted to see how the t variable looks like. So it seems to be counting milliseconds. Now the animation. How we will do the animation. So let's say that our Bezier curve, I would like it to be a loop, maybe. You know, like in this old screensaver. And the loop was composed of several like control points which were bouncing around the screen, and I think the center points were bouncing, and I think their control points were also somehow evolving. I think they were rotating or something like that. So we'll need some kind of data structure to record this information. We will use an array, obviously, right? At 10 points. Random radius and so in this case we have a curve, and what we'll do is we will track many points along a curve, and each point has like 2 control points, and we will rotate those control points slowly around the siema. We will rotate those control points around the point. Yeah, and I guess that should work nicely. So the way I'm actually implementing it is I'm pretty much describing what I intend to do, and most of the work is actually done by Copilot. Let me also start some music. Okay. And how does it look like? Angle seems good. Yeah, everything seems good. So in our drawing code, so Bezier curve. Okay, we need, so when we draw a new segment of a Bezier curve, we have to pass a control point from the previous kind of point. So we kind of iterate, so we can't iterate over points. We have to use the old school, yeah, iterate like that. Some random error. No clue what's happening. Yep. I think the error was related to this web page. Probably the code that we are writing kind of looped infinitely or something like that. Anyway, so control point 1 is the position of the previous point. Good. Cosinus of the angle times radius. For the current point, we don't need to add those arms. And for the last point, rather than adding, we should subtract. Okay. And this is how the preview looks like. Okay, it's something. Now we should also have some velocities. So I don't want the points to stay in the same place. I want the points to kind of move and keep bouncing on the screen. So rather than randomizing the velocities like that, let me just randomize an angle and use sinus and cosinus to find the components. Yep. Yeah. Okay, and it means that we can start animating. So we are adding velocity like that. Cool. So we have pretty animation. Let me also scale the radius. Cool. That looks nicely, although it is a little bit fast. So I think the problem is that is there a problem? Maybe you can just lower the frame rate and that should be enough. So let's remove this and this. And this is 60 FPS, 30 FPS. Let's reduce the velocity. Or this dt. Yeah. Let's divide by 1000 so that we have a number in seconds. Okay, so the curve seems to be bouncing nicely. There is a small glitch at the end of the curve, which I would like to fix. There is a discontinuity here. Okay, I know why. Or do I know why? Let me think. So, okay, I guess we will have to draw something. The way our curve works is that we have a control point, is it called control point? It's just a point. So when we are drawing a segment that looks like that. So when we draw a curve, the curve by default, it starts with the point where the curve was last moved to. So here we should do move to the position of the last point. So that's what we should do. Then when we are starting, we are taking so this point here is the last point. This is the CP1. This is CP2. And this is like the end point. Like, yeah. So we are calculating CP1 based on the previous point. CP2, okay, we should calculate based on the current point. Yeah, and the end point is just the current point. Cool. Yeah, that starts to look nicely. One more thing that we could do is we could play with colors. So can we do something like that? Oh no. There is an API in Canvas that allows some global alpha compositing. I would have to check the documentation to see how it works. Actually, no, that's not very important. I want to have a cool color. So I will pick something like this. Yep. And I would like to change the compositing operation to something that will darken the image. Yeah, so let's check the documentation. Global composite operation. Yep. Something like color dodge or color burn. I guess we will try each of them. You know what? Yeah, let's do this. So we will have an array of all composite operations. I just want to try them all out. And to try them all out, I will first reset to something sane. Clear the canvas, right? So we have a nice white background. And before we draw our Bezier curve, I will first change the operation to to a random, not random, to a sequential, you know, the next one in the sequence from this array. Yeah, just like that. And also, not 5,000, let's go 5,000. So for each composite operation we will see it for 5 seconds, and I would also like to see it, so yeah, exactly. Okay, this is source over. This is, I have no idea what. This is source setup. Destination over. We cannot see anything, okay. Probably destination in. Destination out. So those first couple of blending modes, they are boring, right? Okay, lighter. Here we cannot see anything because the background is white. Then copy, which is probably replacing everything. XOR, that gives interesting effects. Multiply looks nice, much nicer than the default. Screen, nothing. Overlay, nothing. Darken. Lighten, I saw a small hint. Color dodge. We don't see anything. Weird. Color burn. And hard light. Exclusion. Hue. Okay. Hue, saturation. Okay, let's keep luminosity. Let me remove the boring blending modes. Let me also accelerate their change so that they change every 2 seconds. And let me change the background slightly, because we couldn't see much. And that was probably because of the background. So instead of having a white background, I will create a slightly different color. Let me change this a little bit. So I'm tweaking the color values so that each channel has some value. It was like 0.3. 0.3 is like very small. If we want to kind of have nice effects when it kind of accumulates by being drawn over itself, yeah, this number has to be higher, like 20 or higher. How does it look now? Yeah, this blue color is kind of nice. Let me add something bluish. Oh yeah, like this one. And I will slow the animation because 2 seconds is not enough to see the effects. This is copy. Copy is boring, let's remove it. Sorry, it's kind of glitchy. So we have multiply, which looks like that. Nice. Screen, which is very, very subtle. Overlay is interesting. Color burn creates some nice, you see those color patterns? And highlight is also nice. Okay, color burn, I really liked this effect there. Oh well, difference is also nice. Color burn, pretty nice. I really like color burn. Yeah, soft light is like really awful. Difference feels kind of similar to color burn, but with like a different, like it feels like color burn but in a negative. Anyway, we are switching to color burn. We just tried all of the blending modes. Color burn is the nicest. Yeah. Now, another thing I would like to do is I would like to make the lines thicker, but not just increasing the thickness of the lines, because that would be kind of, you know, boring. Yeah. It just looks more clunky. I want to change the shape of the, so that, you know, the points of the curve which are moving quickly, I want them to be thicker, and the points which move slowly, I want them to be thinner. So if you look at those lines, if you look at those two subsequent lines, I would like to fill the area between them. And the area between like the next pair of lines, I would like to leave empty. So I will have to I will have to kind of draw this twice, I think. I don't know how do you draw a line with a hole. Let's see. How to draw a line with a hole. I guess we cannot begin a new path before stroking. So let's try doing this. And so we have a first path which is closed, and then we have a second path which is like identical. So let's try save and translate it a little bit. I just want to see if we can create like a path with a hole. So this is how it looks right now. So let me check documentation. How do we make a hole in a path? Direction? No, that's not it. Maybe you could clip or something like that, but it's not easy. Okay, we have to go in the opposite order. So we don't need those translates. We don't need this save or restore. we have our first path, which draws nicely. So in this situation, let's just do it like that. We'll just copy this path part here. So we are starting from the last point. So we're starting with point 0. The previous point is, let's just rename them. And maybe I cannot see anything, so maybe let's try stroking. Something is not right here. This loop is broken. No. Ah, yeah. That should be -1. This doesn't look so great. So for some reason it is, so maybe we screwed up something in those coordinates. So let's see. Maybe we should change the signs here. Oh yeah, that worked. Yeah, and the animation looks nicely, and the width of the line, and it behaves really nicely now. So I'm introducing an additional variable which will say how thick the lines should be. So here, when we advance like the empty part of the line, we will multiply this by 1 minus fill. And here, when we are doing the line itself, we'll multiply by fill. Okay. There seem to be some problems. So okay, here is a problem. If it's lower than 0, like so. And the same for the y coordinate. And let me create a function out of this, because this is a nice piece of code. Let's call it move points. Yeah. There is a bug in move points. Let's see. Oh yeah, we don't have DT. Yeah, we have to pass it. This all looks nicely. Now let me also create some minimal radius. Okay, and the points, they are starting to look nicer and nicer. Maybe we could increase the speed of movement. And one thing that we could do is, so when we are drawing the nice, the colorful strips, it works nicely. But the space between those strips, it's completely transparent. So I would also like to draw something there. So I'm thinking about doing a small change. So basically I would like to repeat this section here, but instead of drawing the colorful strip, I will be able to clear the space between the strips. So here's what I'm thinking. The same, but multiplied by 1 minus fill. Yeah, and we can remove this. this looks weird, but that could be good. So now we're drawing this strip, but with like two colors. Once with the blue and color burn, and once with yellow. Maybe I will also use the blue. I remember that difference was also looking nicely. Well, it's an interesting effect. Yeah, but this is slightly too heavy. And this, on the other hand, it removes too many details. I would like to something like that, but with higher alpha. How does it look? I'm not sure if it's better. Let me comment this out. Yeah, that's not what I wanted. Yeah, same here. So now, let me remove those. Okay. And lower the frame rate. Let me also lower the speed. And scale of the curve. And maybe add the margin. So I'm adding this margin around the edges so that the so that the points of the curve, they don't go too far outside. There is some bug here, apparently. Yeah, now it should be good. What else would be nice? I think this should fade quicker. Yeah. Maybe even slower frame rate. Now we can reduce the number of points. So with 6 points. Increase the margin to like 50. Oh, and when we randomize the initial point position, let's do it like that. Let me fade this even quicker. Maybe like that. There are some... The graphic looks a little bit too jumpy. I would like to make it smoother. So when it's rendering at 60 FPS, this is how it looks like. The lines, there are just too many lines and they are too packed. At 30 FPS it looks like that. 20 FPS, still acceptable. 10 FPS, and now it's jumpy, suddenly jumpy. So what I'm thinking is maybe I could do this in this more expensive way, where rather than fading the background, we can just draw each line on every frame. It will be slightly more expensive. Because what else we could do to make it smoother? Yeah. Because I was also thinking about somehow like adding new lines, slowly, so that they would, fade in. But probably it's not a good idea. Instead, let me do this. Let me try to do this using a loop, yeah. Rather than fading previous frame, we'll just draw everything from scratch. Like that. And because we have done that, we have to change how we work with points. So we have a global array of points, and we want to move it, slowly, very slowly. Yeah, you may see some artifacts here. We're drawing very thin lines right now. That should look cleaner. So when we have our array with points, I think we'll have to copy it because we want to draw several stripes on each frame, like 5 or 10. So we cannot move our only global array. We have to kind of keep the old value somewhere. So let's pass it explicitly. We create a copy of our points. We have a lot of points TMP to fix. And everything now stopped moving. That's good, that's good. So here we can move our actual points by some step. Yeah, like so. And here we will have a loop. Like so. So here, when we move our points, we don't need to use dt anymore. We can use a constant here, like 1. That's too much. Yeah, that looks interesting. Okay. That looks like a nice animation. Let's also add a few more of those, maybe like 8. Feels too much. Cool. Now we have a pretty nice animation. So I have this idea. So here, if we move this like begin path and fill outside of the loop, then we should have some nice, slightly different kind of composition effect. Yeah. Now they kind of are like XORing with each other. Which is interesting. And it seems to like pause from time to time. Probably we're not super like memory efficient, or we're probably allocating too much garbage. Yeah, like those CPs. Yeah. Let me see. This margin. Maybe we could have a bigger margin. Smaller radius. Yeah, it's behaving in an interesting way now. Okay, that was a nice experiment, but let me actually feel it like that. I liked this effect more. Now, we could probably do one more thing. I've just noticed that on the edges, sometimes we have this like dip between the two strips. So when one strip comes like that and its other edge comes like that, we should have like a line, like a solid fill here, and we don't have it. Yeah, it's a small effect, but slightly annoying. Let's see, maybe we can somehow fix it. No, I don't think it will be easy to fix. We would have to find like some endpoints and connect them, and it's not easy for Bezier curves. Okay, so let's leave that. So okay, this effect looks nicely, but I would like one more thing. I would like to add a gradient so that this curve is not just blue, but like shifts between blue and other colors. So how could we do that? Option one is we could have like a gradient fill in the background, and we could use this gradient fill. So here, rather than specifying the color directly, we would just specify the color as a gradient here. Actually, let's try that. Let's change the colors. And here we will have something like like this. And here we could probably use so the gradient will move along with the first point. And quite frankly, it's not a bad idea. Yeah, let's keep it like that. So next thing, let's slow down the movement a little bit. Now we can increase the number of points. Okay, this is a nice simulation. Now, it's not over. Obviously, it's not over. Let's continue. So I would like to, because right now the points, they are just bouncing around. And I would like to change the behavior of those points so that rather than having those hard bounces, I would like them to smoothly bounce off the walls and smoothly push each other away. Okay. So the key function, or actually no. So I was thinking that the key function would be the move points function, because this is the one which kind of progresses the simulation further. But we have kind of two situations where we use move points. Once when we advance the animation forward, and second when we kind of draw each of the 8 strips. I'm not sure if it will kind of be stable or whether it will work anyway, but we will try. So here, when we are iterating over points, we will do two nested iterations, and here we will have some kind of force between them. Yeah, and I see that the copilot already kind of figured out some kind of force that we could add here. Yeah, and as you can see, it's not super stable. The line jumps around on the screen. So let's look what Copilot added and figure out what it did. So it finds the distance, finds the f. This is very weird. This is very weird. Let's find the force differently. Yeah, angle we will keep. Let's try to create something like gravity, maybe. So gravity has like 1 divided by d times d. Let's increase this. Some funny effects are happening. But okay, let's keep increasing the force. At 100 it starts getting slightly wobbly. So let's limit it. Okay, let's just bump this as much as we can, as long as it's stable. It should be good. If 1000, yeah, with 1000 it starts behaving funny. With 100 as well. And so right now we cannot really see the points where they are and what they are doing, so let me also draw them. So we'll have some kind of blobs at each point. Okay. And I must have forgotten how to draw arcs, so let me check. It's just arc. now we see our points. And the first point the one which is, oh sorry, not the first point, the last one, the one which is like at the end, is the one which is actually being simulated. And there should be some gravity happening between this point and other points. Will they meet? No, they didn't. Okay, those two could meet right now. They didn't do much. So let me see what we are doing. So when we are dividing here, let's divide just by d. That should give higher, much higher force. Some funny things are happening, and I'm not entirely sure what it is. It's absolute value. Certainly the shape that we are getting is interesting, so that's nice. We have that going for us. Maybe we can change direction. I changed the formula for force to 1 to, just see how it's behaving. So essentially when it's 1, it means that this point, which is currently at the top, should have a force which pulls it down. I hope so. So essentially all of the points, they should be like gravitating towards the center. Or actually, this is a small change that could fix the stability of this whole thing. We could, instead of doing simulation of every pair of points and doing this gravity of every pair of points, let's do a center of the canvas, and this is the point that will be the center of gravity. And if we have just one, center of gravity, we can also play with different forces. So rather than gravity, we will have spring. So if a point goes too far away from the center, it will be pulled back to the middle. Now, we could, for example, say that the force is proportional to the distance. And it seems to be working. So let's increase this to 100 so that the force is higher. Okay, and now we could remove the collisions with the edges because the force seems to be so high that it's not necessary. And also remove the balls red balls. And we have something that's, I would say, pretty... So it's fairly smooth, but it's very messy. And there are too many points in the center. They are like bumping into each other and it doesn't look nice. So I will try to... I guess I have to go back to the n-squared simulation. But okay, let's do this. Okay. I am playing a little bit with this value so that when we have this center point, right, the force will be proportional to the square of the distance. So the points which are far away will be pulled strongly towards the center. And the points will also pull each other away, but so I guess I have to increase the max force, maybe 200 here and maybe 50 here. It's very unstable. So the way I am doing the simulation is I have this global array of points which I'm modifying, and then based on this modified I do the simulation in a loop, right? Because this is the actual simulation when I move all of the lines, and here when I move each of the strips I'm kind of like predicting in the future kind of where they would be, and this prediction doesn't, it's roughly correct but not exactly, so we have those funny oscillations. The funny oscillations, they will like decrease if I decrease like the number of strips. Right? If I have just one strip, there are basically no oscillations. If I have my 8 strips, you know, the ones at the end are behaving crazy. So how do I fix it? I guess I will just lower the forces. I will lower this force and lower this force significantly. Or actually, this doesn't have to be so low. it is more stable now, right? Those crazy jumps. I guess they are caused by this force. Or not. I have a square here, so I guess that square. So this oscillation happens when we are very close to the center. Yeah. Let's see, this point is going to cross near the center. It's jumping, jumping. After it passes the center, it stops. And now it stops. Okay. So when D is very small, funny things start happening. Let's try that. You know what? We'll have to change the approach completely, because those funny oscillations, which are coming from our predictions, we'll have to do them differently. So I'm thinking that rather than predicting them, like predicting the trajectory of each point into the future, which is not correct, it's like, you know, weather predictions. We will keep a record of the point position across the last, 200 frames. It's super cheap. We could just have like an array with like historical point locations. And I think if we have this array, then we will be able to just use the historical point locations to draw those points. However, it's kind of late here, so I will be finishing the stream now. Thank you everybody who joined. I see a lot of people. I will resume the stream on Friday Europe time morning, so something like 10 a.m. Europe time. Yeah, and I guess that's it. Thank you and see you around.